Hi everybody, welcome to week 5 of Advanced Java Programming. I realized I made a mistake because this would be a really good class for people to attend in person. And thank you guys for showing up. I should have given people a heads up. It's kind of like last week's where it's like we're going to talk about some fundamental stuff that might not be super relevant now, but you're going to want to know it. So, I'm sure everybody who's watching the recording will be jealous and they're not getting it in real time and will follow along at home. So I think thanks for coming. I think you guys are going to get a leg up on the Android stuff. So here's what I'd like to talk about tonight. First off, we'll do Prime Minister's questions. I'm curious to hear how your Project 3s went and what you're thinking about on Project 4. Then I want to take the first steps with Android. And what I want to do is kind of like what we did last week, where last week we spent time in class making sure that everybody could, everybody who's got a laptop could at least get started with the project and stuff. We're going to do that with Android. We're going to set up your development environment just to make sure that everybody on their various machines on their various platforms can run Android Studio. So a little unusual, and I'll talk more about Android and some of the caveats and stuff like that then. And then with the remaining time in class, I have up here that we could do a code kata, but I'm guessing that it might be a better use of everybody's time to sort of have a Project 4 lab. I know some people have gotten started, and I'm guessing that some people just finished their Project 3 today and wouldn't mind some a little more structured discussion, or just an opportunity to sort of do, maybe pair up and try to figure out your Project 4 and then come back, talk about what you learned, make sure that everybody knows how to debug and how to run it. Does that sound like a good use of time? Okay. So that'll be the plan for tonight. We'll see how it goes. Okay, what can I tell you? How was your Project 3? What questions do you have about either the assignment or some of the concepts that you encountered? Observations you have for about sorting and working with dates and times, all that good stuff. How is Project 3 when compared to the first two projects? Easier. How is it easier?
Because we had the boilerplate of the previous Project 2. At least in my experience, I set it up in a way that it was easy to extend. So.
Oh, okay, good. So you're seeing some of the benefits of making it extensible. Okay. Was that generally other people's impressions too? Did Project 3 seem a little bit more approachable?
Yeah.
Seeing some nodding, some good. Okay. Awesome.
Question.
Yeah.
So I did the overriding the compare to method for the I think it was for the appointments, and then all I did to sort them was after I had written the comparing function method, I just called sort, but I don't know where that sort method is coming from. Is that coming from some kind of API or?
Was it collections.sort?
It might have been.
Yeah.
I just bet it just sorted it automatically based on my compare to method, and I was that. So what's going on there?
Sure. So this is in the lecture, but I'll reiterate it. So objects. So you've got objects, and you can compare them for equality with the .equals method. And then there's a notion of ordering objects, right? Objects represent things, and some things might be ordered. Let's say they're numbers, or let's say they're records in some system, and there's some way of ordering them, like alphabetical order. So you're sorting a bunch of people or whatever, and so you can sort their last names in alphabetical order, for instance. Sometimes some types of objects are naturally ordered. That means that there's an intrinsic order to them, like strings. They have a natural order of being, let's say, graphically sorted. Integers, same thing, right? The integer that represents 2 comes before the integer that represents 3. And when a class has this natural ordering, the way that you express that in Java is by implementing the comparable interface. So the comparable interface is a standard interface. It's in the Java lang package. And it says, hey, any class that implements this comparable interface knows how to compare itself to some other object. Almost always an object of the same class, right? And so that's what the compare to method does, right? And so those of you who implemented it said, okay, great. Here's the assignment specified a sort order, and then you implemented that sort order, that algorithm, there in your compare to method. So comparable is, again, a standard interface, and so then other APIs take advantage of that standard interface. So for instance, when you call collections.sort, you give it a collection, and the contract that collection.sort has is that, okay, you're going to give me a collection, and I expect that everything in that collection is going to implement the comparable interface. And so what does it do? Well, it iterates over that collection and then uses the compare to method that's there on the, every object in that collection supplies to then do the sorting.
So if you didn't say implements, this interface, and you called one of the collection methods on it, it might say like this method doesn't actually implement whatever you're trying to do. Like
so yeah, let me look at the API real quick so that I can give you a good. Let's see here. Let's look at collections.
So when you override it, you're not giving it a natural ordering anymore,
Oops,
right?
wrong API. Well, let me show you. So let's look for collections.sort. Great. So collections.sort. Okay, let's look at this signature. And then look away because it is scary looking now. Collections.sort. Okay, it takes. Okay, so there is a class capital C collections which contains a bunch of helper methods that work with your collections. There's a method called sort that takes a list and doesn't return anything. It just reorders it, I guess, so removes and adds things to that list. Now, looking at this signature, there's this type T. So, a number of people have asked me, because you see the type binding in your projects, right? So your appointment book, the abstract appointment book has a bunch of appointments of type T, where T is something that extends abstract appointment book. In this case, abstract appointment. In this case, it's your appointment. And the reason I put this stuff in the assignments is to get you used to the fact that there are parameterized types in a lot of the Java APIs. So what this is saying is this T here is some object that extends comparable, and it's a comparable of what? Well, of some object to another object that is a super type of T. This gets really kind of hard to read, and this is why you let the IDE do the heavy lifting for you. But really what this says is that, hey, you're going to have to give it a list, and whatever the type of list is, it's got to be something that implements comparable. Okay, so here, you give it a list of your appointments. Well, since your appointment implements comparable, the compiler will be really happy with it. So if you are using strongly typed collections, then the compiler will complain if you try to call sort on a list of something that isn't comparable. So the compiler protects you if you're using strongly typed collections. Otherwise, there'll be, right there you go. And then otherwise, a class cast exception will be thrown if the list contains elements that are not mutually comparable. So if you have, let's say you had a list of, let's say you had a list where you didn't specify the type, so you get type erasure. Then you get a runtime exception saying, hey, wait, I expected these things to be comparable. I expected things to be implement with a comparable interface, and they don't. You get a class cast exception, a runtime exception. So this is one way to sort your collections, and this is perfectly fine. There's another way, though, that I think is more elegant and requires less code. So, as you'll recall from the lecture, there's this whole class hierarchy of all the collection classes, right? And you've seen some of them, array list and vector, and we saw the map interface, right? And we saw how to use all of that. So all these are in the collections API. There is a type of collection called a sorted set. Now, do you guys remember what a set is in Java? What's a set? Yeah.
Only one of each thing that can't be duplicates.
Right. It's a collection in which every element in the collection is unique. Now, how do you determine whether or not an element is already in a collection or not? How does it know? Because you can take any type of object. How does it know? Has to iterate and...
If the comparison operator returns 0.
Yes, but it doesn't have to be comparable. It uses a different method to determine whether or not it's already in there.
Does it use the hashing or something?
It doesn't have to use hashing. If it's implemented underneath the covers using a hash set, it will. But it doesn't have to. The contract is the dot equals method, right? Every object in Java has a dot equals method. It knows how to compare itself to something else. And this isn't an identity equality. It is a semantic equality. It's like, oh, hey, does this other object represent the same thing that I do? And so that's what a set is, where all of the elements of that set are unique. And the sorted set is a subinterface of set that says, okay, not only are all of the elements unique, but they're also sorted. Now, why don't I just look at it? That's a good idea, Dave. Okay, so sorted set. Lots of good stuff. When you create one of the sorted sets, what the hell's all that? Oh, okay. So let's look at an implementation of sorted set like tree set. Now, when you create a tree set, you can give it's got various constructors, and one of those constructors takes something called a comparator. So there's the comparable interface and there's the comparator interface. Now, when you have an object that doesn't have a natural ordering, or you have an object that does have a natural ordering, but you want to sort it using different criteria, use what's called a comparator object. So a comparator, if you look at this interface, a comparator has one real method. Oh, they add it made it so hard to read when they add all these default methods. There you go, compare to. A comparator has a method called compare to that takes two objects and says, okay, great, how do these objects sort against each other? And so it has sort of the same return value semantics as the compare to method does. So if the first one is greater than the second one, it returns a positive number. If the first one is less than the second one, it returns a negative number. And if they're the same, it returns 0. Sorry, where's it go? Oh, so then back to the sorted set, or in this case, the tree set, which is an implementation of sorted set. You can say, oh, give me a tree set and use this comparator to compare the elements in it. So it'll sort it automatically. You can also create a tree set with an empty, if you don't pass it any parameters. It sorts it according to the natural ordering of its elements, meaning the ordering specified by the comparable interface. So one way of implementing the sorting in Project 3 is to have your appointment class implement comparable, and then instead of using an array list to store your appointments in your appointment book, just use a tree set. And tree set will take care of all the sorting for you. And so it all happens sort of automatically by the fact that you're using a different collection to store your appointments. And the nice thing about this is that this is literally a one-line change, right? So instead of saying new array list, you say new sorted set. A sorted set is also a collection. So if you're programming to the interface and just have your get appointments return a collection, poof, everything just works. Anyway, so neat little lesson there. Any other observations about Project 3? Nope. The cones were also due this week. I saw lots of submissions, so it looks like most people got them done. Thank you. I hope you saw the benefit of starting early on those, because there were a lot of them. They got kind of hard at the end. What were some of your learnings there? What were some of the cones that either made you go aha or made you go arr? We should take the Python course instead. Yes.
It was one of the ones at the end with the currency,
Currency, yeah, and the date formatting too. Yep.
I think that was pretty much just pretty much deleted and just checked until it ran through.
And yeah, what was what was challenging about that?
Well, yeah, even though it said I expected this particular string or output, even though it matches, it's still not recognized. So you have to check specifically what aspects that had to be besides that exact string.
Do you have something on that? Oh, sorry, first next to you.
Yeah, just add on that. There was one where there was it was like a char array being put in, and then it translated into a string array, and since it or to a string, and then it kept all the
zero padding at the end.
Yeah, all the zero padding at the end. And if you look at the comparison between the two on the checker, it's they're exactly the same.
Right, prints the same. Yep. There are a couple of those, and it's all part of the larger lesson. It's just because you print something out, the standard out, doesn't necessarily mean that it looks the same. That one is oh look, there are all these trailing zeros, and so then your C programming comes back. It's oh right, got all these null characters in there. And on the currency, it's kind of the same thing, where like it looks the same printed out, but clearly it's not. And this is where I advise go into the debugger and figure it out. And so you'll see that yes, maybe the characters are actually what did the difference end up being? So what did you have to do to get that one to pass? Okay, that's fine. But it was probably a matter of either special characters being printed or or maybe that dollar sign isn't what you think it is. I can't remember how that's solved exactly. But yep, it's tricky in places, and this is the kind of thing that you also see in the real world, where especially with date formatting, with time formatting, with all of this localization, you're going to see things that will print differently in different situations. So we can get a character encoding. That one's fun too. We're doing it all in Japanese. Okay. Other observations about the cones. Overall, was it a good use of probably hours and hours of your time? Feel you learned something, I hope? Yeah, kind of.
Some of the later ones, yeah.
Some of the later ones, yeah. Right, I can imagine the first handful was like, yes, well, both 1 and 2, I know addition. That's good. Okay. Sweet. What else can I tell you? What other questions do you have about where we are right now in the course? Nothing? Okay. Let's talk about Android. I've always... One of my goals for the course is to give you an opportunity to experience contemporary software engineering. And for the entire almost 19 years I've been teaching this course, part of what I want you to experience is user interface programming. Right? You've probably spent most of your academic career working with the command line. Maybe you've done a little bit with HTML. We see a tiny bit of that in Project 4. But let's be honest. I mean, no one uses command line programs. Well, people use command line programs, but it's like the same Unix stuff that's been there for like 30 years now, right? People aren't writing new command line interfaces, or if they are, sort of those patterns are understood. And it's not, and with modern software, the vast majority of our users are interacting with a Windows-based system, not a text-based system. And so then I try to reserve the last couple weeks of the course for doing user interface development. Over the years, the technology for user interface development has evolved quite a bit. So when I started teaching the course, it was the Java Swing libraries, and what you wrote is a thick client that ran natively on your desktop. And that was cool, and that was neat because you got to see how, hey, look, the same Java code can be used to display, to write a user interface both for a Windows program and for a Mac or for Linux or for X Windows or whatever it was back then. But that's sort of fallen out of favor. People aren't using desktop applications as much as they do, and they're not really writing them in Java. For several years, I used a web framework. So the next thing that's sort of like starting in 2009, 2010-ish was writing rich user interfaces for the web. And we used a tool called Google Web Toolkit, which let you write a lot of your code in Java, but then it all got compiled down to JavaScript and made for a neat project and everything. But that technology has become passé. No one's using that anymore. Not even Google's using it anymore. And so while it taught some neat lessons, it wasn't terribly practical. So last year I promised myself, okay, it's time to get hip and modern, and let's write some Android. So who here has heard of a phone? Okay, good. Thank you for raising your hands and laughing at my jokes. Android is a platform for developing small device applications. So it's not just phones, right? I mean, they run on tablets and inside cars, everything like that. It's a nice open platform. And while you can develop in a number of different programming languages for the Android platform, The first one, and probably the one that's still most popular, is the Java programming language. And so this is good, right? So you can use the things that you've learned in the first 4 weeks of the course, 5 weeks of the course, in terms of using the Java APIs, in terms of using the Java language, all the programming patterns, all the things with unit testing and dependency injection, which you might learn about, stuff like that, and apply it to building these small device applications. However, because you're developing for a small device, instead of running something on the command line on your PC or on your Linux machine, there's a slightly different tool set. And so what I want to do tonight is get everybody using the tool set. And so I'm going to walk through. Oh, sorry, and one more caveat. I've never taught this before, so I have no idea how this is going to go. I hope that'll be approachable to you. And sort of reading through it, I think we're ready for it. I think it'll be okay. But it might require, but it's not going to necessarily be as familiar and as linear as the beginning of the course. So then, as you're planning out the rest of the term, I will provide some slides. I'll try my best to turn it into a screencast. But you might find yourself doing a little bit more research on your own, reading up on it, going through some tutorials sort of outside of the class, in order to fully understand all of the moving parts. And while there are a lot of them, I think what we can do is focus on just the most important ones, so that in 2 or 3 weeks we can get you exposed and write a simple Android application. Which actually, maybe I'll just go into that now. So, and by the way, the materials are still kind of a work in progress. I'm sort of figuring out, figuring out as we go along too. And then, of course, I will take that into account when grading your projects. So, basically, the project 5 is a user interface for your appointment book, and the requirements are pretty simple. Write an Android application that does the same kind of thing as your project 4. Or at least lets the user do the same kind of thing as your project 4. So you've got your appointment book. So you need to create an appointment book, or actually manage multiple appointment books, and create appointments in it, and query stuff like that. But now instead of doing it on a command line or via a REST API, you're doing it in an Android application. Tonight we'll talk about how to install the Android Studio IDE. And really, there's not much structure to the assignment. So unlike in projects 1, 2, 3, and 4, where I'm like, here is your command line, or here is your REST API, I'm not going to tell you what your application should look like. Part of the assignment is exploring Android development, is exploring how to build a user interface with Android. I want there to be a help menu, or a README or something. But other than that, just making sure that your error messages are there. Like if you've got bad input or whatever, make sure to tell the user about it. But really, this is an opportunity for you to be creative, to learn some new things, and we'll see how it goes. Since you'll be developing a user interface, there's a nice tool out there that, as Adobe or somebody creates, called Balsamiq, that lets you mock up your UI, and they have some nice sort of pre-built widgets for Android. May or may not be helpful to you to sort of figure out what you want to, how you want it to look. If you're going to use a text for date and time, it's the Project 4. Which is also the same as Project 3, I guess, format. Sorry, this is out of date. You're not going to use Maven, you're going to use something else. I'm not exactly 100% sure how the submission process is going to work, so stay tuned on that. But don't worry, there's plenty of other stuff to keep you busy between now and then. Generally speaking, are there any questions about the assignment? I know you haven't even seen Android yet, so it's probably hard to ask, but...
So are we using any kind of web, like Jetty type?
I'm going to say no. There's not a requirement. As a matter of fact, I guess that's an important thing to point out. It does not. Let's not bother with any sort of client server. Let's have it all be on the phone, which really the ways wouldn't work in the real world. But hey, if we can get everybody just writing a phone application, I'm going to call that success for the first time. So yes.
How do we test it?
Well, we'll see that tonight. So
Oh, okay.
what we'll see tonight is that we're going to configure Android Studio, and you can then download and install emulators for various devices.
Okay.
And so then, I'll be updating the assignment. And I'll create a Slack channel in a little bit.
So you could have an emulator for like a phone on your laptop.
Yes, and what I'd like to do, and I think we can all do this, is that have everybody develop under using the same emulator, and that's the one I'll test with. So, but I will specify all of that shortly. I'm also sort of banking on the fact that people are probably still focused on their Project 4 for this week, so that's good, that's fine. And that's the right thing. So here again, tonight is sort of getting your feet wet, making sure you can get your environment squared away. So we'll spend, I don't know, an hour, trying to get all of that working, sort of get everybody started, and then we'll put that down for a while you focus on your Project 4. But then next week, I want to be able to dive deeper into Android, start telling you more about the platform and actually how to write the code for it, what all these things mean. So here again, a little different than usual. Bear with me. I appreciate your patience as we experiment with this. I think you'll enjoy it, though. I think you'll find that working with Android is a good use of your Java programming skills that you've developed, and hopefully it's fun. Although it's new and different, and will likely be frustrating at times also. Okay.
Well, will we
Yeah,
still be using IntelliJ for this?
Well, okay, so actually that's a really good question because what we're going to dive into next is installing Android Studio. So Android Studio is a customized version of IntelliJ that has been optimized to work with Android applications. Plain old IntelliJ itself does have an Android plugin, but I've tried to use it and it's not approachable. It's not like you can start from scratch. So the Android Studio makes it much easier to get started. And so I figured, yes, it's another thing you got to install on your machine. And yes, it can be kind of a resource hog. We'll all see if anybody's machine catches on fire. The exit's right there. Or it's there if it's somebody on that side of the room that's catching on fire. But we'll have to see. I found Android Studio to be, in this tutorial, makes it really easy to get started. So, and since it's built on IntelliJ, though, it'll be familiar to you. So a lot of the same shortcuts, you run the debugger in the same way, but it's got some additional features that makes it easy to get started with Android and especially like just get your environment all squared away. So you install the JDK and that was probably a relatively straightforward process. The Android tool set is even bigger, and when you start adding in all these emulators, Android Studio does a good job of keeping all that organized, so you don't need to worry about that. You can instead focus on building your application.
I just posted the link on Slack.
Oh, thanks. Good. Well, actually, and let's, so actually let me create a Project 5. And this is where I'll just put all of the general Android stuff also. Information for Android. A discussion about Android and the and Project 5. Okay, and then is everybody going to try to download this at the same time? We're going to overload the. What was that?
27 out of 1 gigs.
Hopefully, I still have the DMG installed. I created a project. Channel for all things Android.
Really?
Oh dear. Okay. I'll talk slowly. Maybe we need to have an early break while everybody's downloading it. Okay. So yes, everybody is downloading Android Studio. Okay. I will look at my. Gosh, I hope I still have the DMG. What's the name of it?
Android-Studio.
Okay, good. Android dash studio. Oh, good. Yeah, right. You're gonna be here until 10 o'clock. Okay, shoot, I hadn't thought about the bandwidth. Maybe everybody can go to Starbucks. Anyway, okay,
It might
good.
be faster if you upload your DMG to a Google Drive link, and then we
Really?
upload it from Google Drive.
You think so?
I mean, I don't know. It just jumped up to 25 minutes for mine to finish, so.
I bet an hour.
I'm clear at the front of the line right now.
Yeah.
Should I put it on a memory stick? No, I'm not gonna put it on a memory stick. Pass it around. Man, that just like doesn't sound like a. I work for a security company, for goodness sakes. Yeah.
I'm just gonna be on airdrop if anyone wants to throw it at me. Like, just saying.
Can you put it in your PSU
Available.
directory so they can, the Mac users can just download it from your.
Well, but would it be any faster? I mean, if the bottleneck is the network.
What if they all go to different buildings on campus?
Yeah, it's like.
Let's switch it.
2 hours left. Yeah.
Okay then.
Well, we can just observe you and then figure it out later.
Yeah.
I guess. Well, it is recorded, but maybe okay. Well, we'll see. Damn. Okay. Note to self: make sure to ask people to download it next time. Okay. So I still have the DMG, luckily, and so then Bush. So okay, you just install it on the Mac as a matter, and so then, oops, what did I just do? Stop. Yep. So it's just an easy installation. It's just, there you go. Okay, now it's exploding.
We could make our own like physical queue in the classroom where one person at a time downloads Android Studio, and it might go faster than everybody trying to download it at the same time.
Let me guess, you're first.
No, I'm getting it faster from airdrop.
You just finished, right?
Actually, it just made me download. Yeah, so I'm
Yeah.
You get on airdrop.
Okay.
There's 1 minute.
Well, we'll see.
Just go to Finder and there should
Just
be
look up airdrop.
tab for airdrop.
I don't know if it works on Windows.
I don't think AirDrop works on Windows. Okay, so I just installed it. So now I can, oops.
Aiden, can you drop it?
Is it going to be a Bluetooth connection if it's AirDrop?
Jeez.
Yeah, I think the setup process.
That'll be, if it goes over Bluetooth, it won't mess with the Wi-Fi. So give it a try for AirDrop.
AirDrop worked really fast.
It's pretty big.
It beat the download. By
Yeah, that was.
Okay.
I will say that there's an additional step where you have to download all the components, not like 14%.
Oh yeah.
Oh no.
Oh, and I deleted the emulator, didn't I? Oh, that was okay. Okay, so open up Android Studio. Oops. I think I was opening up Android Studio. There we go. Okay, verifying
Is
it.
there something else we should be downloading at the same time? An emulator? Or is that
You'll get there. It'll download it for you.
Okay.
Yep. I am so sure I want to open it. So thinking about it. Gosh, I hope.
You're reinstalling it now. Is this like a fresh install?
Yes. Yeah, I blew everything away prior to class. Okay. So then. More downloading. Okay, well, we'll see how this goes for me. So then, okay, the first thing it needs is the Android SDK. So this is the software development kit for Android. And it is saying, hey, what do you want to download? Okay, the latest version, the API 29. So, you know, like any piece of software, wait a second, I should start it downloading so I can, yep, 129 megabytes. Okay. So, well, that doesn't seem so bad. Or that's just one zip file, isn't it? Anyway, so you know, there are lots of tools with Android, and one of them is the SDK. This is the software development kit, and this contains the compilation tools, a lot of the runtime tools, sort of all of the basic stuff. Now, and here again, this is the nice thing about Android Studio is that it's designed to get all of this stuff for you. There are there are other ways to get it on the command line. There's like, remember Travis CI, that continuous integration service in the cloud. You can have Travis run Android applications, and it will it'll download stuff for you and it all does it on the command line. You don't want to do that. Let Android Studio take care of all of this stuff. Very slowly. This is unfortunate. It was going faster before. Okay. Boy, mark for time. Maybe I should go. Maybe I should start lecturing anyway while you're doing that. Actually, that's what I should be doing. Want to see some really bad lecture notes? We can talk about my stuff. Okay, so Android. Oops. Okay, well, this is unfortunate. Did it stall out? Nope. Nope. It'll be a race to the finish. I mean, I'm doing this for you. And so here's what I'm going to do. I'll just start talking about Android stuff, and we can talk about it, and we'll see how good these lecture notes are. So, here again, as I was saying in the beginning of class, does full screen work here? Actually, let me download it and get some better lecture stuff. Excuse me. Oh, I don't want to download it to. I wonder why it doesn't put it in my download folder. Oh, I know what I can do. I can just open it from here. Open Android.pdf. How's it doing? Slow. Okay. So, okay. So, Android. You've probably heard of the phone, but really, what underlies all of this is the Android platform. And so, this is a series of software, everything from an operating system to a runtime to a windowing library. That is standards based. There's lots of common components, and the idea here is that it provides a stable and secure operating system to deploy small device applications that are meant to run on a wide variety of devices. And let's be honest, Android was really a response to Apple and iOS, where the Apple model is you get one operating system, one runtime, one set of libraries that looks really good and performs really well on one kind of devices made by one vendor, right? You can only run iOS applications on Apple devices. And so we all, love them and things like that. But if you're not Apple and you want to, you want to sell devices, you are kind of out of luck. It was also, and so then for vendors that didn't want to get locked into Apple or Microsoft, they needed a third option. And Google led the effort to create this third option. But anyway, I'll get more to that in a couple of slides. Now, as I said, the applications are really quite powerful and provide everything that you need, or rather would want today in a small device application, a phone application. And they can be developed in several languages. So just the same way that I guess we really haven't talked about that much, but you can have, we have the Java programming language, which is targeted to the JVM. There's similarly, there's the runtime, what used to be called the Dalvik VM, but the Android runtime that runs the equivalent of bytecode, runs compiled code. You can have multiple languages that are compiled down to that runtime. But really, the best supported language and the original language was Java, so it's a good fit for this course. This slide deck is very much a work in progress, but what I will talk about is some of the Android fundamentals. It's like, hey, what are we getting into? And this is, when I think about what I want to teach you and what I want you to learn, especially in a course that's called Advanced Programming, I want to make sure that you understand and appreciate what's happening underneath, in the entire application. And so what I do is I take a very broad and even kind of a bottom-up approach to discussing things like Android. You look at a lot of the tutorials and they focus very much on, here's user interface, and we'll get to the user interface, and that's all very good and very important, but I want to make sure that you understand some of the fundamentals. So we'll talk about those, we'll talk about some of the APIs that you work with, and well, not tonight, but when I write the slides, we'll talk about how to test them. Because, Android applications are modern applications, and everything should be tested, and so you can see, you can write unit tests for them, and there's also ways of leveraging the emulators to run tests too. How am I doing? 73%. Okay, it's good because I'm only on slide 2. Okay. So the content here is meant to be very general and not specific to a particular to like the latest version of the flavor of the week for Android. So this is mainly background stuff. We talk about the APIs. We'll see how they're used. But the intent is that this slide deck is not going to have screenshots of Android Studio. Is not going to have a lot of visual things. This is basically the textbook version of it. And what we'll see once we can get our environment set up is how to use things visually. But this is mainly just me talking about stuff. So there are several parts to the Android platform. There's the hardware itself, right? You're running on a variety of devices. And actually, this is kind of interesting, right? Your projects 1, 2, 3, and 4 ran on like 2 machines, right? On your development machine that you use, and then the PSU machines. Well, Android applications are meant to run on dozens and dozens of different kinds of devices. And so then this is something that you need to understand and consider when you're developing your application. As we'll see, Android has a number of features, and the fact that it is that you have all these different platforms, all these different form factors, right? I mean, phones are of different, phones from different vendors are from different sizes, and even one of the interesting things about small device applications, which is different from writing UIs, is that you have things like the device can move, right? I mean, you don't, most desktop applications, or at least traditional desktop applications, don't have to worry about the user turning their laptop on their side and having to do something reasonable, right? But you do with a phone. This is part of the user experience to say, when the form factor, a physical form factor of my application changes, I want to behave differently, right? So I think about the YouTube app where you have it in portrait mode and it's got, here's your video and then here's all the comments. You turn it into landscape and all of a sudden, poof, it goes full screen. Right? It's just a different dimension of developing software. So when you think about an Android application, the Android platform, there's the hardware, and then there's the operating system itself. So this is different from like your Java program, right? Where of course there's an operating system there, but that's really not something that you're worried about. It's really not part of Java. Java is on top of it. Well, Android includes the operating system, and it's Linux. And this is really a good thing. And they leverage the operating system and features of the operating system to provide security, to provide all of the process and resource management. So that's all handled by the operating system. And of course, the operating system does what operating systems do, which provides an interface between the higher level software and the lower level hardware. Now, unlike, traditional PCs or laptops, phones have all sorts of neat hardware, right? They've got GPS, they've got the thing that detects motion, cameras, Bluetooth, all sorts of stuff. So and this sort of the thing when you really start thinking about it, these devices are really complex and really powerful, and so then the operating system needs to work with that to expose that to the application developer, and therefore also the application developer. Android also has something called the runtime, the ART. And this is, you can think of it as equivalent to the Java virtual machine. It's the thing that takes the Android application and runs it. And so then it's the thing that takes the application and has an interface with the operating system. It provides a runtime of its own to do things. It's got APIs that it works with. This is, there's some interesting things that the runtime does for you. So, for instance, when you, install the application on your on your device, it goes through and it optimizes it for that specific device. So you create your application and you bundle it up and you deploy it to the Google Play, the App Store. It sits there, and then when it installs, it says, "Aha! I'm being installed on this Galaxy 17 whatever it is phone," and so then it goes and the Android runtime will then optimize it for that device, probably doing things like pruning out stuff that isn't relevant for that device, compiling things, translating things into device-specific native code. And again, this thing was originally called the Dalvik virtual machine, but it's evolved quite a bit since then. I think it's a complete rewrite and offers some really nice things. Let me check the download. Oh boy. Who are the people that provide Android? So there is a consortium called the Open Handset Alliance. It's also a terrible name for a band. That is basically a lot now of technology companies that care about Android, that care about this open platform. And so it's a ton of device manufacturers, right? Anybody who makes a phone, anybody that makes, small devices for cars or set-top boxes or things inside TVs and all that kind of stuff. They're part of this. They help evolve the platform. And then also, they make that. I'm sure it gets them access to, to early versions of the software, and they can help influence how it works. And so then, while on paper they're like, oh, hey, it's all about this open platform. What they really care about is Android. Android is it's not exactly open source. There are parts of it that are open source, but they say free and open. Meaning that people can use it, and that they want it to proliferate. They want lots of people to use it, and so part of their mission is they say, hey, listen, we're going to standardize some aspects of the platform, and they focus on the things that are standard so that you can write lots of applications for it. And then the individual vendors, the individual companies then can focus on specializing, certain things like making a better camera than the other person, or providing a very different form factors, or putting inside wearable devices, all that kind of stuff. Then is what the vendors can specialize because they're sharing a platform for everything else. There's the SDK, and I don't have any details about it. So, and here again, the intent here is like, okay, I'll go through and I'll talk about all the different tools, which if you're using Android Studio, it's good to know that they exist, but hopefully you won't be invoking too many things from the command line. Now let's talk about programming in Android. Let's also check in our downloads. Okay. So there is, as part of the runtime, as part of the APIs, there is a huge class library of Java classes that are used to build Android applications. And so the whole idea is that much like your Project 4, where you're writing a servlet, right? Remember how we talked last week that the servlet, there's that servlet API. And the API is what you program to, what you interact with, and all of that. That API is ultimately implemented by some piece of software like Jetty, but you don't really care about that. You're just writing to that interface. It's the same thing with Android, in that what your application does is that it provides objects, Java objects, that are then invoked by the Android runtime during different points of the life cycle of your application, and then depending on where your application is in its life cycle, your code provides certain things. So sometimes it'll be things like, oh, okay, my application is starting up. I am going to create all my user interface objects. Okay, I'm going to create my user interface. And then other times it's like, oh, okay, my application is shutting down, or my application has been, we'll talk about pause and stuff like that. But anyway, you react to all of these changes in the Android application's lifecycle. But it all starts, or at least most applications start, with an activity. So an activity, this is a very fundamental concept inside Android. And what it does is it provides basically, well, the interface for performing a single task. So things like, viewing all my appointment books, or, viewing an individual appointment, each one of those is an activity. And this is a very important abstraction in Android because it's the thing that the user interfaces with. And it's also activities also have this life cycle, and they, as part of that life cycle, they come and go. They're displayed, they're hidden, they're created, they're destroyed, things like that. A couple other things that I want to mention, but we probably won't be using in our projects. There's something called a service. A service is another sort of first-class citizen in Android, but it runs in the background and it does something. So, for instance, it'll provide data, or maybe it will, most of the time they provide data, or it'll do some background computation. They'll download something. Those kind of things are services. So this isn't something with a user interface. This is a piece of your application that's running in the background. And more importantly, an application can access the services of a different application. So, you might have a service that, again, is responsible for downloading stuff from the web, and in your application, you can go call that service and have it do some work. And that's called a component binding to a service. And then basically you get a Java object that represents that service, and you can go and interact with that object. Now, as we're all familiar with, lots of, especially phone apps, small device apps, are very asynchronous in nature, meaning that you have the Twitter app on your phone, and that as people are tweeting stuff that it thinks are interesting of you, it'll send you all these notifications. And so that ability to send and receive events is a first-class citizen in Android and is represented as something called a broadcast receiver. And these events can come either from another application or from the operating system itself. Oh, your battery's running low. Oh, you just discovered a new Bluetooth device. All that kind of stuff is then represented in this broadcast receiver. Finally, an important part of your application is something called the manifest. And the application manifest is the thing that configures your Android application. It tells you sort of like how your application is defined, how it's configured, what the requirements are, especially the security requirements. And I have a slide of security, but all that is configured in the manifest. So as you're developing your application, you'll need to add stuff to the manifest to make sure that it runs and it can do what it needs to do. Hey, look, it's almost 6:30. How about we take a break? So then maybe they'll let things download for a little bit. And then, boy, I hope we'll be able to do this tonight, but we might have to change tactics here. Anyway, let's take 10.